You're not going to want to miss this episode of the AI Show where we look at batch inference with something called a parallel run step and more. Next episode, don't miss it. We'll see you then. Hello and welcome to this episode of the AI Show where we're talking about batch inferencing. I have my friend here, Vaidya. How you doing, bud?
Hey, I'm doing great. Thanks for having me.
Tell us who you are and what you do.
Yeah, I'm Vaidya Sambasivam, Program Manager in Azure AI, focused on machine learning model inference. And I'm here to talk about the new batch inferencing capability in Azure Machine Learning that allows customers to run inferences on large-scale data sets.
So let's get a little bit of context, right? Because it feels like when you say inference, what does that actually mean for people that haven't heard that term?
Absolutely. So stepping back on machine learning, you typically start with data with known answers to your problem.
Correct.
And then you build a model that predicts those answers accurately to start with. And once you have a trained model, the next step is to put that model to real test against real world data that it has not seen before.
I see,
right?
I see.
That's when you do inference, and depending on the scenario you're focusing on, you're looking at real-time inference, where you want the responses to come back immediately, where you typically expose a REST API endpoint and a request response low latency pattern. Or for those scenarios where instantaneous response is not mandatory, you could process this offline asynchronously, right? Good example of this could be like offline fraud detection, lead generation, demand forecasting. There are numerous scenarios around this.
And this is interesting, right? Because like foolishly, I always thought, hey, I put this model out and I need to predict right away on single things. But when you look at the way these things are set up, of course there's going to be some scenarios where not only do you want to do it offline, but you have to because there's no other way because you have a lot of data.
Yes, you're talking about terabytes of data here being processed offline to get inferences in a highly scalable, performant, and cost-effective way by fully leveraging the power of cloud.
That's awesome. So now that we know why batch inferencing is important, can you tell us what it looks like inside of Azure Machine Learning?
So we handle high volume basically using 3 steps.
Okay.
Right? First, we partition the data. Right? So using the power of Azure Machine Learning dataset.
Okay.
Dataset is a resource for like exploring, transforming, and managing data inside Azure Machine Learning. And the next step is to delegate these inference workloads to the auto-scalable Azure Machine Learning compute.
Okay.
So it scales. And then once the results get done, the output is automatically stored in user-specified storage.
I see. So let me see if I understand this right. Because this is sounding very similar to like the experimentation pattern, except now we're moving it to inference. First, we have data sets. In the data sets, we farm it out like we kind of used to do for experiment. And I'm spitballing here. You tell me if I'm wrong.
Yes.
The cloud, the compute, like the clusters will scale up and down depending on how much you're doing. And then it will put the answers somewhere where you tell it.
Absolutely.
Did I get it right?
Absolutely. And once the job gets done, it tabs down the VM and you don't pay anything. So you get the cost optimization aspect as well.
That's fantastic. Okay. So now that you've told me all of this gloriousness, I feel like I need to see how it works.
Absolutely. So for enabling this capability, just to set some context, we're using the Azure Machine Learning pipeline.
Okay.
And pipeline, for starters, as we all know, is a set of computational tasks that you stitch together to enable a machine learning workflow.
Correct.
Right? And we have added a new step called ParallelRunStep to do the processing. Right?
That's awesome.
And which enables this auto-parallelism using the data set, as I mentioned, or it enables scaling through the Azure Machine Learning compute. The key thing about the parallelism is that there is no user orchestration here. In the past, user has to write the MPI code to do all this complex logic.
That makes sense, yeah.
Right?
And that's smart because when it comes to batch, you don't really need to do it all in sequence. You're like, here, you take this, you take this, you take this, and then output to the same place. That's cool.
Absolutely. And we have support for 2 data sets, right? For both structured as well as unstructured data set. Structured data set could be a CSV, TSV, or even like a Parquet or a SQL query. Unstructured could be a file or a blob.
Or like for me, I do computer vision. It could be a folder of files, for example.
Yep.
That's fantastic. All right, so let's see some code.
Absolutely. So for this demo, I'm going to show a digit recognition model that is already trained using an MNIST data set.
Right, cool.
And for the convenience, I've converted all the input into PNG files. So we could show the file data set in action.
Which is cool, because everyone knows you can download MNIST in a CSV or into it's a zip file of bits, right? But this is actually more of a vision scenario.
Yep. And I'm going to walk through the notebook here. I'm going to skip through some of the generic steps, which is like, for example, connecting to workspace.
Sure.
Workspace is a container, like it's an artifact where you have all the machine learning artifacts.
Cool.
You connect to the workspace. You assign machine learning compute here. I've assigned a CPU cluster here, but you can also do a GPU.
Right.
If you want to do
For
parallel
MNIST,
stuff.
I feel like CPU is enough.
It is more than enough. And here you specify the input data store. We have a blob container here where we copied all the files, and we are pointing to the output data store. This is the interesting piece where we have the file data set to now manipulate the data,
Okay.
right? And to reference the files here. And this is the MNIST data that I spoke about, and this points to the PNG files. Now, if you want to play with structured data, you could use the tabular data set as well here.
That's cool.
All right, so we download the model and we register the model in the model registry.
Or you could use a model that's already in the registry too, right?
Yes, absolutely,
Correct.
absolutely. And then you wrap your inference script here. Right? This is consistent with what we do for real-time inference.
And this is I've already seen all of this.
You
goodness.
initialize the model, and then you have a run function that runs inferences, in this case, for a subset of models.
I see.
You run inference for a subset of files, and you take a parameter called mini-batch, which controls the number of files that get run for every run execution.
I see.
Right? Conda dependencies, again, this is a standard step. The crux starts here. Right? This is the parallel run step. That is the configuration input for
see.
batch inference, where you define the score.py, you define the file input. I mentioned about the mini batch size. These are the number of files that get executed in every single run
Yeah,
execution.
got it.
Error threshold is an interesting parameter, right? This defines the number of files that get ignored for
there's an error.
errors.
Got it, okay.
So in this case, if it exceeds 10, it's going to automatically stop the job. So it saves you a lot of cost.
And that's smart because, like, for example, for some reason, maybe someone submitted an MNIST digit that was full color, which is
Yes.
the wrong tensor shape, it'll break it.
Absolutely.
But if someone, it doesn't happen very often. Or, for example, the alpha channel is, and that's going to break it as well. This is a way of being able to say, yeah, that one, okay, let's move
Right.
on to the next one.
Right.
That's cool.
All right, and then you create a pipeline step, which has got the model and the input and output, and then it's an experiment run from there on, right? Where you run the experiment, and here is a result that I processed a few minutes ago. It shows the first 10 files that got recognized.
So as I'm looking at this, I'm coming to an interesting, and you correct me if I'm wrong, as I come to these realizations sometimes during these videos, as you know. Like, this feels like we're talking about batch inference, but a parallel step can be used with anything, right?
Beautiful question,
yeah.
right? If you think about it, it's like a parallel map operation. So you
Right.
could use that not just with the model as input, but also for actions related to inference. For example, pre-processing, post-processing, and so on, right? For pre-processing, a good example is you might want to reduce the size of your images before sending them for inference. Standard use case.
For example, TensorFlow, you could put it into a TF record set, for example, which is really smart.
Yes, or even for post-processing, you might want to put some bounding boxes on top of the images to see what objects are detected from your detection model. You could do all these operations, right? It's a parallel map operation that you could take advantage of this step for doing that as well.
Because in theory, like, there's certain operations where it's like, look, we just need to do a thing on all the things. Well, let's scale up some machines and do the thing on all the things in separate little batches, right?
Absolutely. It boils down to how you leverage the auto-parallelism and the auto-scaling capability to your benefit. Whether it is by using model as an input or without it for pre and post-processing, it works for both scenarios.
That's amazing. So just to finish up, can you summarize what we've seen today and how can people learn more?
Yeah, we have looked at how we could use the parallel run step in the pipeline to execute your batch inference jobs in a highly scalable, performant, and cost-effective way for large-scale data sets.
And this is pretty cool because, like I said, there's a couple of vision scenarios where, like, I literally need to go through every file, make sure it's the right size, make sure I convert it into a batch of TF records. Like, that's not inference, but it's something I could do with this. If I want to do inference, I could do that. I mean, there's a ton of cool things here.
Absolutely.
Awesome. Well, thank you so much for spending some time with us. Thank you so much for watching. We're learning about the parallel pipeline step. Did I get it right? And how it can do a number of things, including batch inference, which is a really good use case.
It's called ParallelRunStep.
ParallelRunStep. Thank you. We want to get that right. Thank you so much for being with us, friend.
Thanks for having me.
Thanks you so much for watching, and we'll see you next time. Take care.